Now here's example 2 from class 15, rigid body kinematics using the instantaneous center of rotation. So this is the same example that we did in class 14, and so we can make as a means of comparison. So we start with this crank AB that's rotating at 4 radians per second, and this has an ICR. It just happens to also be the connection point right here. So here's the instantaneous center rotation is at A, and it is rotating clockwise, so its velocity is coming down this way. That we can find VA, and that's a VB. It's going to be equal to that length AB times the angular velocity of AB. So that's going to be 0.15 times 4 radians per second, and we get 0.6 meters per second. We don't need to put the trailing zeros on there. I wanted to make this clear. Okay. Now for this other link up here for the connecting rod, we once again want to make a very careful sketch. So I will get my old driver's license out here and make a sketch. By the way, you can't see me do this, but I held the card up against the length of the thing, and then I shifted the card, tried to not rotate it and move it down so I would get a parallel line. Similarly, and hopefully we did a pretty decent job of this right here. We could take that card, make a parallel line, hold it, and try to transfer this velocity right here of B is going to be right here. So here's the velocity of B. Now we know that the velocity of C is going to be in this sense, right? We don't necessarily know which direction it's going to be. We will in a second. But we want to be careful that we don't use that line we just drew for the ICR. The one we want to use is one that's perpendicular to it, right? So we want to extend down a line perpendicular to that. And now we want a line that's perpendicular to the velocity, but also we remember that this line right here was perpendicular to the velocity. That's supposed to be perpendicular right in there. So it actually extends down here. If I were to superimpose it up here on the original drawing right here, we might take some notice that they get really close to each other, but this ICR right here does not equal that ICR right there. Okay, it does not equal point A. It lands further away from it. But point A does land somewhere on that line. That's something to be aware of. Okay, so in terms of the geometry. But in looking at the geometry here, we do see that there's 30 degrees right here. So therefore, oops, I didn't draw that line very well. Come on. This angle right here is also 30 degrees. So we have right here, this is 30 degrees right in there. We also note that from over here, this is 30 degrees, right? So we could convince ourselves of that because this is 60 right here. It has to be this 2 right here would be 60 degrees right there, right? So it's this line right here has to be 60 degrees. Therefore, this has to be 30 degrees, right in there. So breaking this down apart right here, we know that that is also 30 degrees. Similarly, we can other angles we can find is this is 60 degrees right in there up to that point. And looking a little bit more closely up on here, we could see that we extend here that this is 60 degrees, and therefore this is 60 degrees. Now, I'm just showing you how I'm breaking this thing apart right here. There might be an easier way to go about this. If there is, I don't quite know what it is off the top of my head, but it'd be good to, educate myself on this and try to, you could try to point something out to me. I'd also point out that I think, looking at this again, I believe that my diagram is a bit flawed in terms of, because we're going to find out there's going to be symmetry, because if we take this, now what we have 120 degrees right in here, and this 30 degrees, our conclusion is that this right here has to be 30 degrees. And if this is 30 degrees and this is 30 degrees, then this length right here, let's see, orange, this length right along here has to be equal to this length right there, because my sketch isn't very good, because these should be symmetric about this after we've worked through what those angles are. So this one is going to be, we're told is 0.2, so this length right here is 0.2. And so this R, let's call it, this is going to be C, yeah, because this is C right here with respect to ICR. ICR, not RRC. ICR. I wonder how many times I've already done that. So this is the ICR right here. And we could figure out what the angular velocity of this whole thing is going to be. It's going to be in this direction. That's going to be the omega BC. And we can find omega BC by taking the velocity of B and dividing it by RB with respect to the ICR of the connecting rod. So that's going to be our 0.6 divided by our 0.2, or we end up finding that we get 3, I stuck some sig figs in there, radians per second, and it is going to be clockwise, interestingly enough. And this agrees with our previous problem. Now, if we want to get the RC with respect to ICR, there's definitely a couple different ways we could use it. But let me use law of sines. We can find it with law of sines. And just take RC with respect to ICR, divide it by the sine of 120. Ooh, that's ugly. I hate that thing. 120. And that's going to be equal to, I guess I decided it was going to be LBC divided by the sine of 30. Right, so R ICR is equal to 0.2, that's the LBC, divided by the sine of 30 times the sine of 120. And we end up equaling 0. It's not true. Yes, it is. Okay, 0.3464 meters. And so if you want to find the velocity of C, that's going to be RC with respect to ICR. That's what we just found, times omega BC which ends up equaling 0.3464 times our 3 radians per second. And we get 1.0392 meters per second. You can see that, which agrees with our previous example. And so this one wasn't too bad, but you might got a little lost as I stammered through the process of finding the angles right there. So you might want to try it yourself and see if you can work through those kind of basic geometry kind of things where we're trying to figure out which angles are which going through there. That's really the struggle in ICR, is getting the geometry correct. So that was example 2. It's a 10-minute video.